Okay, welcome back. We're going to look at a couple of special triangles today and some special angles that we often sort of focus on in trig. The first triangle off to the left here is your basic isosceles, where the two legs of the triangle are the same length. And of course, if the two lengths are the same length, then the two angles have to be as well, so they're 45-degree angles. With using the Pythagorean theorem, and remembering that c has to be our hypotenuse, or the isolated variable has to be our hypotenuse, we can solve for the missing side, and it ends up being root 2. In the 30-60 triangle, 30 degrees here, 60 degrees here, again, right angle triangle, obviously. We can find the missing side. It turns out that a 30-degree angle helps me establish that my opposite over here is a 1, my hypotenuse is a 2. And so, same sort of idea. The hypotenuse is isolated, and we can plug in numbers and solve to find the missing value here is root 3. So how are we going to use those? Basically, we hopefully remember sine, cos, tan. SOHCAHTOA is kind of a standard mnemonic that's used to help us remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So if I look at a specific angle then, something like this 45, this will be kind of an initial angle or a key angle. It'll be my starting point. I will always start any trig I do at an angle. So given this angle, the side over here is my opposite. The side right here is my adjacent. Adjacent means beside, opposite means across from. And of course, my hypotenuse is right here. So if I'm looking to establish my angles now, I can look and say that sine is opposite over hypotenuse, which means in this case it's the 1 over the root 2. Cosine is the adjacent, the other 1, over the root 2, and tan is the opposite, the 1 over the other 1. Now, what I've got here are exact ratios for my sine, cos, and tan. If you punch these into a calculator, you get answers like 0.7071. 1 obviously is actually fine for the tan of 45. But what happens is if we try to use those punched in values in calculations, depending on how extensive our calculations are, how many calculations we have to do, how large the numbers are we might be working with, we can throw our answers off significantly. So we want to use exact values for now, and we can worry about punching things into a calculator a little bit later. So in the same way that I established my sine, cos, and tan for 45, I can do for the others here. I've got the green is 30. So this is my initial value, or my initial angle here. Starting from this angle, I can establish my opposite to be over here, my adjacent to be right here, my hypotenuse to be over here. And then we end up with these ratios down below. Opposite is the 1, hypotenuse is the 2. Cosine, root 3 is the adjacent, and 2 is the hypotenuse, and tan is 1 over root 3. And then, of course, if I wanted to do if I was working from the 60-degree angle, my opposite ends up being over here. My adjacent is here, and my hypotenuse doesn't change, which gets me the 3 angles on the bottom. Those 3 angles I will use kind of moving forward. Those 3 angles. Those 3 sets of ratios I will use moving forward. If I need to, I can always refer back to them on this page. What you'll do come test time is basically establish, draw your triangles at the top of your sheet or to begin your sheet, and then you can kind of refer to them when you need to. So last thing then, how's that going to help us? Well, I've got a couple of little things here that probably need to establish before we can actually do questions. The first I call the butterfly rule. And basically what it tells me is if I have this butterfly pattern, then each of the angles, and I mean, I guess that shouldn't be a terrible surprise, each of the angles on the inside is the same. And the sine, cos, and tan, so the ratios between the opposites in each case, the hypotenuses in each case, and the adjacents in each case will always be the same. And so if I want to find an angle that's not in that sort of 0 to 90 range, so not just kind of in here, but potentially further over or potentially into the negatives, I can do that understanding that somehow those ratios will be related to the 0 to 90 that are sort of the standard triangle angles. And so last thing to note then, this is my 0 angle, my 90 angle, my 180 as I move around the triangle, as I go around the circle to establish new triangles. Those are the number of degrees in the circle, and those are the number of degrees I consider in solving these problems. Negative angles then would just go the opposite direction. There's my negative 90, my negative 180, negative 270, and again, back to the starting point, or in this case, negative 360. So any number of degrees you see that are not in the 0 to 90, this is what we're talking about. They will continue on past the 90 degrees and go further. If they're in the negatives, they'll continue on past the negative 90 and go further that way. And then the last thing is this C, A, S, and T, what we call the cast rule. This helps us establish where various ratios are positive. In the first quadrant up here, all ratios are positive, which means that if you have tan of an angle between 0 and 90, or cos of an angle between 0 and 90, or sine, they will always be positive. Over here, sine is positive, and only sine is positive. So something in the range between 90 and 180, sine is positive, the other two are negative. And here, of course, tan is positive, and over here, cosine is positive. And so how these two new diagrams will relate is once I establish which of the 4 quadrants I'm in, I'll know whether my angles are going to be positive, or my ratios, are going to be positive or negative based on whether I'm dealing with sine, cos, or tan. Okay, so we can do a question here, and hopefully things will get clearer as we do them. Sine of 150. So what do I need to know? Where my sine of 150 is. Well, if this is 90, sorry, this is 0, this is 90, this is 180, sine of 150 fairly clearly will lie in here. What I'll do then is kind of using the butterfly rule. That's a really ugly butterfly. Probably do a little bit better job than that. I'm going to establish, first of all, what my related angle will be. Well, if this is 150 degrees, then the angle on the inside here will be the 180 that would have taken me all the way to the end, minus the 150 I've used up, and so a 30-degree angle on the inside. And what that tells me then is that sine of 150 will be related to sine of 30. And the only question is, in this quadrant, the second quadrant, is sine positive or negative? From before, that's another one, cast, C-A-S-T, S. So sine is positive up here. And so that means that sine of 150 is actually exactly equal to sine of 30. And sine of 30 we saw before was 1/2. And that's my final answer. So do a couple more and just see if it starts to make a little bit more sense. So cos of 135 degrees, negative 135 degrees. Basically, I'm headed this way. I'm going to have to go through the 90 and on to a certain distance this way. This is my negative 180 over here, though, so I'm not going to reach that line. So basically, I've got this line here. I can turn it into a butterfly. And I only do that because I want to make sure I know which angle it is I'm dealing with. I'm not dealing with the negative 135 anymore. I'm dealing with the angle that's missing on the inside of this triangle. It has to be the angle inside the butterfly. So 180 degrees would have taken me all the way to the end. I've used up 135 of them to get to this point. So again, that's a negative 135, but the distance is 135, which means I have 45 degrees more to go on the inside of my triangle. And so that tells me cos of negative 135 will be related to cos of 45. And again, the only question is, in this quadrant now, do I have a positive or negative? Well, cos is positive over here. They are all positive here. Sine is positive here. Only tan is positive over here. And so cos of negative 135 is equal to negative cos of 45. And cos of 45 was 1 over root 2. So this is now going to be negative 1 over root 2. And now's maybe a good time to mention, sometimes you will see a slightly different answer here. And what people will often do is rewrite any fractions that have radicals in the denominator or roots in the denominator so that they no longer do. Finding an equivalent fraction here, I have negative 1 times root 2 in the numerator, root 2 times root 2 in the denominator, and so negative 1 over root 2 and negative root 2 over 2 are the exact same answers. So last one, we'll go with tan of 210. Give myself a little bit more room. And 210 degrees means that I'm essentially going to end up down here. Again, 90 to this point, 180 to this point, and then continue on another 30 more. And so my butterfly looks like this. So tan of 210 is going to be related to tan of 30. When I think about the cast rule, C, A, S, and T. So down in quadrant 3, tan is positive. And so tan of 210 is going to be exactly equal to tan of 30 degrees. And I haven't memorized these yet. Tan of 30 degrees is 1 over root 3. Now, I just kind of last comment about I haven't memorized these yet. One of the things I've often said is Math is not about memorizing rules. It's not necessarily about memorizing numbers either. If and when I ever have to do a question of this nature, I always just start by creating my special triangles on the first page. It's quite easy to do. I know that sine of 30 is 1/2. And I know that in a 45 degree, if I have 45 degrees as my angles in the other triangle, the two lengths will be the same size. And so I can establish that they're just both going to be 1. I can find the third side, and I can work out these ratios quite quickly whenever I need to. And so I find it's easier than bothering to memorize everything, just to quickly, if I'm doing a test, if I'm doing work like this, sketch it out really quickly, write them down, and just have them available. It saves my brain space for other things that might be more important. So I think that covers what we need to see. Obviously ask questions as you need to, and talk soon.